All right, now what I'm going to do is I'm going to take you through the process of what a hacker would do. Let's go get in the mindset of an actual hacker attacking an organization and how they would use this third-party data to exploit your company potentially. As you can see here on my screen, I have that LinkedIn data cleaned up. So it's actually in 3 columns. Column A and B are redundant. LinkedIn, the username and email are virtually the same thing many times. So we've just split it out into 2 different columns, which in some cases will be different emails or different username versus email. Anyway, column C is the actual MD5 hash, which I was just talking about, and column D is decrypted password. This is what a hacker would do. A hacker would take the data here in column C, MD5 hash, and in our example, we're talking about samplecompany.com, examplecompany.com, excuse me, and they would take this data and they would go over to a tool called hashkiller.co.uk. I'm going to refresh it. This is a well-known white hat hacker penetration testing website in the UK, and they've been decrypting MD5 hashes since August 2007. So about 10 years now. Here we are, almost in the summertime, 2017. And for the last 10 years, they've been using password dictionaries, rainbow tables, and high-powered graphics cards to render or to begin to brute force decrypt these MD5 hashes. And as you can see here on my screen, 829 billion unique decrypted MD5 hashes since August 2007. And if you actually count the SHA-1 hashes, it's over 1 trillion. It's unbelievable. Now what we're going to do is we're just putting a batch of MD5 hashes from our examplecompany.com, and we're going to put them in this side of the equation. And all a hacker would have to do is type in the actual CAPTCHA right here, press submit, and then in 3 seconds, look what comes out. The actual decrypted format into the plain text. This is scary because what this is allowing for is an actual hacker or hacking group within minutes to query, let's say they want to attack some big US Fortune 500 enterprise. They're able to query that data and say, oh, here's 500 employee emails. And let's say that only 300 still work at the company, because again, that data was taken a few years back. But some of those, let's say that some of those 300 are privileged users. This is where it gets scary, because they're going to decrypt the actual plain text password phrase, which the user most likely is still using in some fashion or another. You say, why? Trip, most people have to change their password every 3 months. But look, you can argue that passwords can be changed every 3 months, but the problem is, if you can see my screen right here, this person who has the password sbird87, if they're forced to change their password, they're going to change it to sbird88. Or if they're forced to have a symbol on the end, it's going to be sbird88 exclamation point. So it becomes very easy for a hacker to brute force and to actually get in to their present day password, or I should say, to get understanding on what their present day password is. 99% of consumers out there and common users of companies will use the same password internally for the company as well as externally for their personal applications day in and day out. And when they're forced to change it, all they're going to do is they're just going to add a numerical value or increase it chronologically by 1 digit or potentially add a symbol. Most of the time. Very, very rarely do they switch that phrase. Think about it. Think about the passwords that you've used over the last few years. Unless you're the exception to the rule, most likely you're using the same type of password, some type of significant phrase. Could be a son, a daughter with maybe some numbers or symbols on the end, your significant other, or maybe a favorite football team. And you're not going to change that. Most people don't, because they don't want to have to remember new things. So therein lies the problem and the vulnerability. Because look, let's say that this user, this person in row 5, who actually has a plain text password of sbird87, let's say his name is John Smith. Now, how would the hacker find that? Most companies have a very standardized email format of first initial, last name at companyabc.com. Or they have first name dot last name at companyabc.com. So the hacker, out of that email, he just goes into LinkedIn, and he can derive what the person's full name is. Let's say they don't have the actual first name, all they have is the first initial. They'll take that last name, they'll put it in LinkedIn, and they'll put in the company name, and boom, what comes up on the search results? The person's full first name, their last name, their title, if they're still working at the company or not, and what their current position is. So this type of knowledge, which is publicly available, will allow the hacker to go in and say, oh, this person's name is John Smith, sbird87 is a common type of password phrase that they use. It might be changed a little bit. It might be sbird88 with those capital letters, B-R or B-I-R-D, but they can see what his title is. So let's say that he is the CFO of the company. That would be a nightmare, because now, even though the company didn't do anything wrong, they might have the best security policy in the world. Because of a third-party data breach that happened years ago, they become vulnerable in present day 2017. And the hacking group can go and begin to exploit John Smith. And obviously he has sensitive data, that he's a privileged user at the company. So he would have access to all sorts of revenue forecast numbers, budgetary numbers, budgetary applications. And hackers could go in through the cloud and try to access their network or different applications that they have based on John's email and this common decrypted password. So that's a vulnerability that we want to make sure that people are aware of.